Hey everyone, this is Greg from ChemCore. In this video, we're going to be going through the worksheet, alkyl groups and molecules, and phenyl versus benzyl. Now, in the first couple problems, we're trying to consider which alkyl groups will make up the following molecule. And so to clarify, what this question is really asking us is it's asking us to identify the molecule or the alkyl group that's on the left side of this carbon, as well as the alkyl group that composes the right side of this carbon. And so remember our quick mnemonic MEPB, my excellent protein bars. So M is 1 carbon, E is 2 carbons, P is 3 carbons, and B is 4 carbons. And so methane, ethane, propane, butane. I see 2 carbons to the left of the oxygen, and so I do have an ethyl group up to the left. And out to the right, I see a benzene ring, which means that I could have either a phenyl group or a benzyl group. However, remember that this free carbon, this CH2, makes it a benzyl group. And so my answer choice should be C, ethyl and benzyl. Now the next problem is kind of referring to the same concept, except we are talking about this alkyl group to the left and this alkyl group to the right. And so to the left, I count 1, 2, 3, 4, 5, 6 carbons, meaning that I do have a hexyl group here. And on the right, it's a little bit of a trick. Now, in the video, the topic video, introducing phenyl and benzyl groups, I said that phenyl groups can often be abbreviated as pH. And so at first glance, you'd kind of look at this and say, oh, we have a phenyl group, right? pH. But we have this free carbon. And so this phenyl group really just refers to the actual benzene ring. But this free carbon, this CH2, makes it a benzyl group. And so this type of question is really good at making sure that you truly understand the difference between phenyl and benzyl groups. So your answer choice should be C. The next problem is asking us what alkyl groups make up the following molecule. Again, to the left side, I see one carbon, which is definitely a methyl group. And to the right, I kind of see this complicated structure. And so what I can kind of determine is that I have 1, 2, 3, 4 carbons, meaning that I do have something with a prefix but, right? And so my answer choice will definitely be methyl. I can probably eliminate A and C. And so the difference is between butyl and sec-butyl. Now we didn't really discuss common names, so if you're not quite sure on what's the difference between butyl and sec-butyl, now butyl, it would be if I connected this butyl just by the end. But since we're kind of connecting it by the secondary carbon, and if you're not sure what a secondary carbon is yet, don't worry. This is methyl and sec-butyl. Now in this problem, again, we want to identify the alkyl groups. To the left, I see these 3 carbons, which definitely means this is a propyl group. So I can eliminate C, and that's it. But to the left, I see this complicated structure with 1, 2, 3, 4 carbons. The problem is that, well, it's definitely not butyl, because butyl is going to be the perfectly straight chain form. Instead, this is kind of this R group coming off this carbon. And so this kind of butyl group is actually called isobutyl. This is isobutyl. And if you haven't gone through the common names video yet, don't worry. Or go to the common names video and come back to this worksheet, because this will make a lot more sense. And so we can determine that the answer is A, isobutyl and propyl. The next problem is asking us to identify and highlight the hydrocarbon functional groups present in the molecule. So we're starting off with a pretty easy example. This is literally the whole molecule is our hydrocarbon functional group, and we can call this alkene, right? This is the alkene functional group. In the next problem, we have this triple bond is our hydrocarbon functional group, meaning that this triple bond is our alkyne hydrocarbon functional group. And so I really want to remind you guys, why did I not highlight these single bonds? Well, in the video, I mentioned that alkanes are technically not functional groups, because they're the default of hydrocarbons. Hydrocarbons kind of like at the default, at basic settings, are alkanes. Any deviation from that point are considered functional groups. Now in the next problem, we do have this triple bond over here, meaning that this is an alkyne functional group. But at the bottom, we also have a double bond, meaning that we have an alkene functional group. The next problem, I have this double bond off to the side, meaning that I do have an alkene functional group. Now the next problem has a benzene ring, and so every time I see a benzene ring, I kind of stop to myself and think for a bit. Now, what is this benzene ring connected to? This is kind of a free carbon, this empty carbon. And so I can highlight this entire thing, including the carbon at the end, calling it a benzyl functional group. However, the next problem, we see this benzene ring again, but at this point, our carbon directly connected to the benzene ring is no longer free. It has a functional group. And so this carbon is now a phenyl functional group. And the alkene, the double bond all the way at the end, is also another functional group. And so I'll use a different color. And so this is an alkene functional group. In the next problem, I do see this triple bond off to the left side, meaning that I have an alkyne functional group. And throughout the rest of this molecule, I do see these double bonds, meaning that all three of these, let's put 3 arrows to show that each of these are alkene functional groups. And so the next molecule, I again see these 2 triple bonds. And so both of these triple bonds are alkyne functional groups. Alkyne functional groups. This as well. But I do also see 3 triple bonds, or 3 double bonds. But I also do see 3 double bonds. And so these double bonds are considered alkene groups. In the next problem, I see this triple bond, meaning that it is an alkyne functional group. I also see a double bond on the left side. So this is an alkene functional group. I also see a benzene ring. And so the first thing I think of when I see a benzene ring is what is the carbon that it's connected to. And so this carbon is not a free carbon. It's kind of that, not that CH2. And so we can consider this a phenyl. In the next problem, I see these benzene ring. And the carbon that is connected to is not that free carbon. And so I consider this a phenyl group. And this double bond over here shows us that alkene functional group. In the last 2 problems, the first of the last 2 problems, I see these 2 triple bonds, meaning that both of these are alkyne functional groups. Alkyne functional groups. I do see 2 double bonds, and so these are my alkene functional groups. And a benzene ring off to the side. And so to look at what the carbon it's connected to, it's a free carbon. And so we highlight that carbon as well, showing that it is a benzyl. Now the final problem, I do see a triple bond, and so I'll notate that first as the alkyne functional group. And now the benzene ring that is right next to it is not connected to a free carbon, and so we consider this a phenyl group. So this is a phenyl group. This concludes the alkyl groups in molecules and phenyl versus benzyl worksheet. If you feel unfamiliar with these concepts, make sure to go back and try the topic video, and maybe go ahead and retry the worksheet. It's always available, everything's always free, and I'll see you guys in the next video.